In addition to your normal standard quadratic factorization, there are two special types of factors. One of them is called the difference of squares because it has a minus in it. And the other one is called the sum of squares. Okay, now you can recognize a difference of squares by the fact that it's only going to have two digits or two terms. Two terms in your quadratic. So a difference of squares might look something like x squared minus 25. Or might look like x squared minus 169. Or it might look something like 9x squared minus 49. Okay, something like that, where we have two terms and a minus sign in the middle, thus difference. Okay, also, the coefficients are perfect squares. So 1 is a perfect square, 25 is a perfect square. 1 is a perfect square, 169 is a perfect square. 9 is a perfect square, 49 is a perfect square. Okay, this is how you can recognize them as being this special factorization. So they always factor to x plus and x minus. Always. Well, in this case, when we have a 1. So the first thing we do is take the square roots, and we get x plus 5 and x minus 5. Those are the factorizations of x squared minus 25. Bam, done. Okay, similarly with 169. That factors to x plus the square root of 169 and x minus the square root of 169, which hopefully you know is 13. So that one factors to x plus 13 and x minus 13. Now our last example here with a 9 in front, we're going to have to square root 9. So square root 9 and we get 3x plus and a 3x minus. So if there's a coefficient in front of x squared, it better be a perfect square or this is not a difference of square factorizations. So 3x plus 7 and 3x minus 7. Okay, those are your difference of squares factorizations. They have two terms, and both of the terms are perfect squares, even if those are just ones. Now the sum of squares is a little bit different. It looks normal, like a normal quadratic, like x squared plus 6x plus 9. Okay, looks like a completely normal quadratic, and it is. Don't worry, it is. So we can factor it like a normal quadratic. What numbers multiply to give us 9 and add to give us 6? And we see that the numbers are the same. So this is going to be an x plus 3 factor and an x plus 3 factor. Okay? Which, in mathematics, we don't like to be redundant. So rather than having an x plus 3 twice, we say that is just x plus 3 squared. And that is the most correct way to write the factorization of x squared plus 6x plus 9. So if you recognize them, they can be pretty easy to do. Like x squared minus 10x plus 25. So what numbers multiply to give you 25 and add to give negative 10? In this case, it's negative 5 and negative 5, which factors to x minus 5 times x minus 5, which we write as x minus 5 squared. So sum of squares you can factor like normal quadratics do, but you write them as one factor squared. And difference of squares you write as an x plus the square root and an x minus the square root for those special factorizations.